So for this example here, cow's milk contains 4.5 grams of lactose per 100 milliliters of milk. And what mass of lactose is present in 250 milliliters of milk? So this isn't that difficult. It's kind of like a ratio, to be honest. It's not really a chemistry question. It's kind of like saying, okay, we have 4.5 grams of lactose over 100 mils of milk, right? And that's equal to, since the ratios have to be the same, they're asking what mass, so we don't know how much mass is present in 250 milliliters of milk. And normally, whenever we have an unknown, we just use like a variable, so we can just use x. So, would you be able to solve for x now? Sorry, I'm going to repeat myself. So, what I usually tell students is to crisscross. So, take the denominator from this side, multiply by the numerator, and then denominator from this side and multiply by that numerator. And now you get rid of the denominators and fractions. So, do you know how to solve it now? Okay, so go ahead and do it. Let me know what you get. Okay, perfect. Yeah. So that should be the answer. 11.25. And remember, the units are important for chemistry. So what is it that we solve for? Yeah. And if you notice when you are setting up the ratio, so mass grams are on top and milliliters are on bottom. So make sure the units are always the same. Otherwise, you have to convert. So yeah. So this is 11.25 grams of lactose in 250 mils of milk. Okay. Okay, question number 2. You can go ahead and read it. Okay, so what do you think? How would we go about doing this? Let's go and see if we can get some of those formulas that you posted. Let's see if that helps us. Okay. Okay, so here we have mass over mass, m over v over v. So which one are we going to use between the three? One of them. I'll give you a hint. See this? So, oh, I guess there's no w. Oh, so weight and mass, I'm guessing they're kind of interchanging. So yeah, I would say the second as well because it doesn't make sense. The other ones don't make sense. So yeah, so we're just gonna use the second one. So mass of solute over volume of solution times 100%. So they said 10%, right? So that means if we're gonna plug in these values into this equation, 10% goes here. So we're gonna do 10% is equal to mass of solute, whatever that is in this case, and we'll get to it, over volume of solution times 100%. So this is how you set up the equation. Now we're going to divide both sides by 100. All right, and that's whenever you're. I'll give you a hint. Whenever you're given anything in percent, 99.999% of the time you have to change it into a decimal form. I don't think I've ever had a situation where you would keep a percent in a percent form, unless if that's like the final answer that you're looking for. So 10% change it into a decimal, divided by 100, so you have 0.10. Correct? You should divide by 100. Usually it's even incorporated in the equation itself. You see how it's times and times 100? So when you're solving, you would divide by 100. So yeah. So don't divide by 100 twice then, if you know what I mean. Like don't divide by 100 and then divide by 100 again because like you used my advice and you're like, oh wait, the equation's also telling me to do it. So just understand, you just have to do it once, not twice. All right. And we know that this is 750 milliliters of solution, right? So that means this is going to go at the bottom, exactly. That's 750 mils. So we have 750 here. And now It's pretty easy to solve for our unknown. What do you think? Exactly right. And what is that equal to? Yeah, and there you go. That's the answer. That would be grams, yes, because it doesn't specify, but it does say mass. And normally, when we're dealing with mass, it's grams. So yeah. Yeah. Okay, let's go on. All right, go ahead and read number 3, please. Okay, so molar concentration. Do you know what the formula for that is? Okay, the equation for molar concentration, it's just C is equal to N over V. That's it. Do you remember that one? Okay, so go ahead and see if you can solve this. This is a super easy one. So let me know. You're solving this, right? Okay, good. Yeah, so N stands for moles. That's right. And do you know what the unit for V is supposed to be? Close, liters. Yeah. So whenever you're doing molar concentration, it's always moles per liters. To make sure you convert 250 mils to liters. Yeah, I got 4.8. Exactly. So good job. That's the answer. Sure. Oh, okay. So it's kind of like going from millimeters to meters or milliliters to liters. It's the same thing. Um, when you're going one way, you have to times by 1,000. When you're going the other way, you have to divide by 1,000. So it depends on which way you're going. So if you're going from something bigger to something smaller, you're times by 1,000, and then here you're going to divide by 1,000. So for our case, yes, yeah, like a bigger. So like for example, if I have 1 meter, that's equal to 1,000 milliliters, millimeters. Sorry. So you're timesing by 1,000, right? Now, if I have 1 millimeter, how many meters is that? Well, that's going to be 0.001. You're going to divide by 1,000. Sure, yeah, go for it. Okay, so yeah, the only thing I wanted to mention is I'm not sure in grade 11 if they're gonna show you this, but see this moles per liter? There's another unit that they use, and that's called molarity, and I believe it's just a capital M. But that, oh, that you've seen that before? Okay, good. Yeah, I just want to make sure that I can't remember if that was grade 11 or grade 12, but yeah, you should know that. So this and this are exactly the same thing, just so you're aware. So, yeah. All right, question number 4. Go ahead and read, please. So this is a little bit more difficult. Um, the thing is, we can use that one. I think, but because they gave us this value in brackets here, we can actually just use this, I think. So I'll show you what I'm thinking. Because they gave us 4.5 milligrams per liter. So that's the same thing as 4.5 milligrams per 1 liter, right? And this was like the first question that we did. Where now they're asking for what volume of water would contain 100 milligrams of oxygen. So now we have 100 milligrams on top, and our unknown value is here. Do you remember the question number 1 when we made a ratio about the milk? And it was like, oh, how much milk is in this much volume? This is exactly that. So if they didn't give us this, I would then use the ppm formula. But because they gave us this value, we can just make a ratio and just cross multiply and do it that way. So you want to do it again? Yeah, go ahead. And we can check if we're doing it right. If we're doing it wrong, then we'll do it the other way. So you should get 4.5 times x is equal to 100, and then you obviously just divide both sides by 4.5, and you said you got 22.2. Okay, and what's the units? Liters. And yeah, let's find out if that's right. Okay, yeah, it was right. Good job. So next question. Did you have any issues with the previous? Okay, so one thing that you need to know is the density of water. So 1 gram is equal to 1 milliliter of water. This is going to become very important when you're dealing with converting volumes to mass or mass to volumes. So you have to use the density of water. So 1 gram is equal to 1 milliliter. So what I would do is, if, for example, if I said I had 250 mils of water, right? How many grams is that of water? 250 grams. It's a 1-to-1 ratio. You're just changing the units from milliliters to grams. So don't make a mistake though. It's not liters to grams. It's milliliters to grams. So that's a little confusing for some students. Yeah. Always, because this is the density of water. It's like an actual observable fact about water. That's its density. Obviously, temperatures and whatever it can change, but like for our purposes, we're making the assumption that it is always 1 grams over 1 milliliter. So whenever you're given a volume of water, you can easily convert it into a mass of water. Okay, so that's kind of like key. That's the main reason why we teach this and use this. So if we were to use this now, if we were to do the exact same question, except using the parts per million equation, which I'm going to copy in 1 second. Give me a moment. So we can just do that. All right. Let's see if we get the same answer. Because that's kind of like the whole point of this exercise. So here we have 4.5 ppm. So that goes here in this equation. So 4.5 is equal to, something over something, mass of solid over mass of solution. Now, what's the solid? What's the solution? What volume of water would contain? So I'm guessing volume of water is my solution, right? Water. And then that means 100 milligrams is going to be here. Does that make sense? And this is times a million. All right, I would like you to do some math for me. So go ahead and solve for volume of H2O. You do divide everything by a million. Because the way to solve this is to cancel that out and do this. So you should get, I don't know, what do you get? Over our x value for now. And now solve for x. How would you solve for x? Yep, that's right. Absolutely right. Good job. And now divide both sides by 4.5 times 10 to the power of -6.